What if I told you that every single time you drive your car, you're basically in command of thousands of tiny, controlled explosions happening every single minute? It sounds a little crazy, right? But under the hood of most cars, that's exactly what's going on. So today, let's pop the hood and see how all that violent energy gets turned into smooth motion. I mean, you get in, you turn the key, and it just works. But that simple act unleashes this incredible chain reaction. It's like a mechanical symphony. So, what is the secret? What's the core principle that actually gets you from your driveway to the grocery store? Well, the answer is surprisingly simple. That's right. It's all about explosions. Tiny ones, but thousands of them every single minute. The entire point of a car engine is to harness the raw power of these little contained blasts. And this whole process has a name: internal combustion. So at its most basic level, an engine is really just an energy converter. It takes all that potential chemical energy that's locked inside gasoline, and through combustion, an explosion, it transforms it into raw mechanical force, the force that actually turns your wheels. Okay, to really see where all this magic happens, we need to zoom in, way in. The main stage for this whole show, the real heart of the engine, is this small, sealed-off chamber called the cylinder. So inside this cylinder, we've got our key players. You see the piston? That's the part that moves up and down. Then up top, you've got two valves, an intake and an exhaust valve, and they act kind of like little doors. And then you have the spark plug. That's our ignition. Let's just quickly break down what each of these things does. The cylinder is our stage. The intake valve is the door that lets the fuel and air in. The exhaust valve is the door that lets all the fumes out. The spark plug provides the spark. And the piston? The piston is the thing that gets shoved down by the force of the explosion. Every single part has a precise job, and they all have to work together in perfect harmony. And that perfect harmony is actually a four-step dance. It's called the four-stroke cycle. This is the repeating sequence that actually generates the power. And in a normal engine, this is happening hundreds of times every second. We're going to slow it way, way down so we can see each step. So get this. Every single push of power is the result of four and only four precise movements of that piston. Let's break down the choreography. First up is the intake stroke. See that blue valve? That's the intake valve, and it opens up. The piston travels down, and that creates a vacuum that sucks a mix of fuel and oxygen into the cylinder. It's basically the engine taking a deep breath. Next up, compression. Both of those valves slam shut. Now the piston travels back up, and it squeezes that fuel and air mixture into a tiny, tiny space. This builds up a whole bunch of pressure and makes the mixture way more volatile. It's ready to pop. And now, the main event: power. Right at the moment of maximum compression, the spark plug fires. Kaboom! The explosion is just immense, and it creates this wave of pressure that violently slams the piston down. This right here, this is the moment that actually powers your car. And finally, we have the exhaust stroke. The party's over, time to clean up. That red exhaust valve opens up. The piston moves back up one last time, and it pushes all those spent gases, all the junk left over from the explosion, out of the cylinder. This makes way for the next cycle, and then it all starts over again, instantly. So we have this piston being slammed up and down over and over again. That's great, but cars don't hop down the road, right? Their wheels spin. So the next big piece of the puzzle is figuring out how to convert this linear up and down motion into useful rotational motion. And this is where a brilliant piece of engineering called the crankshaft comes in. This quote from the Sanger Academy source explains it perfectly. It's the key to the whole transformation. It's mechanical genius, really. And this is how it works. You see, the piston is attached to a connecting rod, which is then attached to the crankshaft. The easiest way to think about it is like your leg when you're riding a bicycle. Your knee goes up and down, right? But it makes the pedal go around and around. The crankshaft does the exact same thing for the engine. Now, that spinning crankshaft becomes a source of power for the rest of the car, and it drives two really important belts. First, you've got the timing belt. Think of this as the engine's conductor. It makes sure the valves are opening and closing in perfect time with the piston's movements. Then you have the serpentine belt. This is the workhorse, powering all the other accessories the car needs to run. You have to remember, an engine making thousands of explosions a minute is creating an unbelievable amount of heat. We're talking enough heat to melt steel. It's also got a ton of friction. Without a few key support systems, that engine will just destroy itself in seconds. And this is where that serpentine belt really comes into play. Yeah, that serpentine belt is a real workhorse. It drives all these vital components. The water pump and radiator fan are basically the engine's personal refrigerator, constantly circulating coolant to stop it from overheating. The alternator is a little generator that keeps the battery charged. And the oil pump? Oh man, the oil pump is absolutely crucial. It circulates oil to lubricate all those fast-moving metal parts. And speaking of oil, it doesn't last forever. As it does its job, it picks up all this dirt and grime, and it goes from a nice, clean, brownish yellow color to a sludgy black. And that is why regular oil changes are so important. It's like giving the engine a fresh supply of lifeblood to keep all those parts from grinding themselves into dust. And there you have it. You go from a simple breath of air and fuel to a powerful explosion, to a piston shooting up and down, to a crankshaft spinning round and round, all the way to your wheels turning on the road. And as our source material says, yeah, it's very complicated, but maybe you understand it a little better now.
For more than a century, this incredible dance of fire and metal has powered our world. It really is a testament to human ingenuity. But as we start shifting toward the silent, instant power of electric motors, you have to wonder, what's going to be the legacy of this amazing machine? What lessons will we carry forward from the age of the explosion? Thanks for joining.